we discussed the two possible cases that we have to consider for estimating a population mean, and how we'll primarily in this class only look at that second case. But regardless of the case, there are conditions that have to be met in order to be able to estimate a population mean at all. First, our sample must be random and independent. Second, our data must come from a normally distributed population, meaning a population that is symmetric and unimodal, just like the bell curve or the normal distribution itself. Or our sample size must be n equals 25 or more. The first condition gets at how the data was collected, which we've talked about briefly with different methods of sampling, and it's a little bit beyond our scope to really assess and validate that. So we're going to assume the data that we deal with does meet that first condition, but we're always going to need to check this second condition to verify that one of those two cases is met, or one of those two conditions is met. So if our data is approximately symmetric, we'll assume that it comes from a normally distributed population, in which case the conditions are met. Using skewness as our determination for assessing whether data comes from a normally distributed population is one possible characteristic or one possible measure we can look at. Assessing normality is a pretty deep topic all on its own, but we're going to rely on this relatively simple measure to use as a rule. If our data is highly skewed, either to the right or to the left, then we're going to take that as an indicator that our data comes from a non-normally distributed population, meaning that our conditions are not met and we cannot estimate a mean. We cannot construct a confidence interval for a mean. Then the other condition is that if the sample size n is 25 or more, the conditions are going to be met to be able to construct and use that estimate. Something we want to note is that this is the easier condition to verify, and it trumps whether or not our data is symmetric or skewed. As long as our sample is big enough, we can estimate means. If the sample size is small, that's when we have to rely on our measure of skewness to determine whether the conditions are met or not. So in example 1, we have a recent study looked at the percentage of people in 35 different non-US countries who replied yes to the question, is religion important in your daily life? The skewness for the data was collected was negative 0.8028, and the question here is simply, are the conditions met to estimate the population mean? We're given a value for skewness, but in this case, we don't even need to consider it because 35 people were surveyed. 35 different countries were studied. So that means that our sample size is going to be 35, which is definitely greater than or equal to 25. So without even considering the skewness, yes, the sample size is 25 or larger. So since the sample size is large, we can estimate a population mean. In example 2, data on alcohol-related motor vehicle crashes was collected from Phoenix over a 30-month period. The skewness for this data collected was 2.623. Are the conditions met to estimate the population mean? Again, skewness is being provided for us, but even though that value would suggest that our data is highly skewed, it doesn't matter because our sample size is large enough Since we looked at a 30-month period, that's definitely greater than or equal to a 25-month period. So yes, in this case, despite the fact that the data is skewed, the sample size is large enough. So we can, in fact, estimate means, or estimate the mean. In example 3, a study looked at the number of emergency room visits for non-occupational firework-related injuries in the first half of July across 24 different cities in 2025. The skewness for the data collected was 1.496. Are the conditions met to estimate the population mean? In the last two examples, we saw that sample size was sort of a trump card when it comes to determining whether or not we can estimate means. So we can start there. In this case, our sample size is only the 24 different cities. That's less than 25, so our sample size is small. That means we have to look at skewness, which in this case is 1.496, meaning we have to say that no, the conditions are not met because the sample is small and the data is highly skewed. Since the data is highly skewed, that suggests the population is non-normal. In example 4, a study looked at a new therapy for teenagers suffering from anorexia. For each participant, weight was measured before and after a fixed period of treatment, which was intended to help participants gain weight. The change in weight for all 21 participants was recorded, so our sample size, 21, is definitely smaller than 25, so we have a small sample. But the skewness for the data collected was negative 0.1189, meaning our data is approximately symmetric. So yes, in this case, the conditions are met because even though the sample was small, the data is approximately symmetric, suggesting it comes from a normal distribution or from a normally distributed population.